Hello students, welcome to the Global Academy. I'm Shaikh sir, your chemistry educator. Today we'll study the unit 6 comes under the organic chemistry and title is the Haloalkanes and Haloarenes for the 12th class or PUC second year students. Now, when you replace a hydrogen atom from the aliphatic compound as well as the aromatic compound by the halogen atom, what you are getting? You are getting alkyl halides and the aryl halides. These alkyl halides are called the haloalkanes and the aryl halides are called as the haloarenes. Now, here in the alkyl halide, the halogen is linked to the carbon, which is sp3 hybridized, whereas in a aryl halide, the halogen is linked to the carbon, which is sp2 hybridized. As we know that halogens are highly reactive in nature, therefore they form a large number of compounds, and in particularly the solvents of the halogens is very helpful in the preparation of many organic compounds. Not only that, these halogen compounds are also useful in medicine, as well as the halogen compounds are also used in our day-to-day life. Let's see what are the subtopic in the unit 6. The first one is the classification, the second is the nomenclature, third is nature of CX bound, fourth is method of preparation of the haloalkanes, the fifth preparation of haloarenes, the sixth one physical property, the seventh one chemical reactions and polyhalogen compounds. Now let's see the first, and that is the classification. So these may be classified as mono, di, tri, tetra, etc. In general, they are called as the polyhalogens, depending on whether one or two or three or more the halogen atom is linked to the compound. Further, the monohalo compounds are further classified according to their hybridization. Either it is sp3 hybridized or it is sp2 hybridized to the carbon atom to which the halogen atom is linked. Now, for example, here you can see the monohaloalkanes, one halogen, dihaloalkanes, two halogen, and trihaloalkanes, three halogen atoms are present. Now, let's see some examples here. We can write here. This is the first example, CH3Cl. So this is a monohalogen. Okay, one the halogen atom is that, and that is a chlorine, and it is called as methyl chloride. Similarly, one more compound we can write, that is CH2Cl, CH2Cl. So this is the second compound, dihalo compounds, and here there are two halogen atoms are there, and this is called dichloroethane. Okay, and here the same way we can also write like this also. Here not necessarily there are two different halogen to the different carbon. It will also have a to one single carbon like this. We can write like this. This is Cl, and CH3. So this is also called as dichloroethane. Similarly, if there is a 3 halogen, we can write like this: CH2Br, CH Br, and CH3Br. So it is a tribromopropane. Okay, CH2 that is, okay, not CH3, that is CH2Br. That is CH2Br. Similarly, in the aromatic, also we are writing here, there is a monohaloarenes, one halogen to the benzene nucleus, and here there are two halogen to the benzene nucleus. It is that is haloarenes, and similarly it is trihaloarenes. So depending on the number of the halogen atoms, either it is called as mono, di, or trihalogen molecules. The next is the alkyl halides or the haloalkanes. In alkyl halides, the halogen atom is bounded to the alkyl group. or they form a homologous series represented by the formula. This is a general formula called the CnH2n plus 1x. This is called as homologous series of the alkyl compounds, okay, or the haloalkanes. Now they are further classified as primary, secondary, or tertiary according to the nature of the carbon atom to which the halogen atom is linked. Based on that, we are if it is halogen atom is linked to the carbon, which is primary, then it is called as primary. If it is a link to the secondary, then it is called as secondary. If it is linked to the tertiary, then it is called tertiary. Primary is represented as 1 degree, secondary is represented as 2 degree, and the tertiary is represented as 3 degree. Now, how to identify these compounds? Which is primary, which is secondary, and which is tertiary? Now, for this, you have to see the carbon. This is important. See the carbon to which the halogen atom is linked. To this carbon, there are 2 hydrogens are there. 2 hydrogens and 1 R dash. This R dash is other than the hydrogen. Then this molecule, this carbon is called as the primary, and that compound is called as the primary compound. And here you can see that this carbon, where you can have only one hydrogen atom is there, R dash and R double dash are other than the hydrogens. Now there is only one hydrogen to link to this carbon where the halogen is there. So this is called as secondary. It has 2 degree. We can write. Similarly, here you can see this carbon where there is no hydrogen is there. No hydrogen. R dash, R double dash and R triple dash all are other than the hydrogen. Then they are called as tertiary that's tertiary carbon, and that compound is called as the tertiary compound. So in this way, the primary, where 2 hydrogen is linked to the carbon where the halogen is there, and secondary, only 1 hydrogen to the carbon where the halogen is there, and in tertiary there is no hydrogen is linked to the compound, and then we called that is the tertiary. Now, similarly, the halides, these are the compounds in which the halogen atom is bonded to sp3 hybridized carbon atom adjacent to the carbon-carbon double bond. Now, in this compound, you can see that this halogen is linked to the carbon. This is the carbon which is sp3 hybridized. And then there is a double bond here. There is a double bond. For example, you can write this compound CH2 double bond, okay, CH2Cl. So this is the compound what you are getting, and this is called as the chloropropene. That is, so this is a compound where you can see that is this type of, where this carbon is sp3 hybridized. Similarly, here also this is the carbon where the halogen is linked, and which is called as sp3 hybridized, and they are called as allylic carbons. Similarly, the benzylic halides, where these are the compound in which the halogen atom is bonded to the carbon, which is once again sp3 hybridized atom, but it is not directly linked to the benzene nucleus, but it is linked to the side chain. And hence here you can see that here this carbon is sp3 hybridized. This carbon is sp3 hybridized. For example, this is the molecule. You can see this is CH2Cl. It is called as benzyl chloride. It is a benzyl chloride. Similarly, here, if you just go on replace one hydrogen, one hydrogen, then you are getting this compound, that is a primary. And if you are removed that secondary, then it is as one more hydrogen, then it is a secondary, then it is tertiary. Likewise here you can also write like this. Okay, CH, Cl2, this is a primary, this is primary, this is the secondary, and this compound is called as the tertiary compound, and this is a tertiary compound. So this is what we are representing. Okay, that is a classification. Hello students, are you preparing for NEET JEE or Karnataka CET? Looking for the right guidance to achieve your dream rank? Welcome to the Global Academy live coaching classes for NEET JEE and Karnataka CET. A single point and a complete solution for the competitive exam preparations, specially designed for 11 and 12 classes or PUC first year and second year students, combining board syllabus with the entrance exam coaching. Our new batches starting from 25th March 2026 for the academic year 2026-27. The course fees is 9,999 now with 50% discount. Enroll for just rupees 4,999 for the entire course. Limited seats are available. For enquiry, call these numbers, and you can scan QR code for the easy payment. Now, the vinylic halides, these are the compounds, okay, in which the halogen atom is bonded to sp2 hybridized carbon atoms. Sp2 hybridized carbon, that is important. Now you have, for example, if you take this, that is CH2 double bond CHCl. So this is the carbon which is sp2 hybridized, and this is the vinyl chloride. This is vinyl chloride molecule, the vinyl chloride, where this carbon is sp2 hybridized. Similarly, this carbon here, this carbon is also sp2 hybridized. Okay. So similarly, you can have aryl halides. Now, in the aryl halide, these are the compounds in which the halogen atom is directly bounded to the nucleus, and also it is sp2 hybridized. Okay. Now, for example, if you take this compound, and this is nothing but this compound, it is called as the chlorobenzene, and this is the carbon, this carbon which is sp2 hybridized, and also this is a molecule also where this is the carbon, which this carbon where it is sp2 hybridized carbon, and in this way these are classified. Then we'll come to the nomenclature. Nomenclature is nothing but the naming the compounds. We have to name the organic compounds by using a rule called the IUPAC system. So what is the full form of IUPAC system? IUPAC system is nothing but International Union of Pure and Applied Chemistry, because this is the one body which governs the everything of the chemistry, either naming or other anything has to be decided, that is decided by IUPAC system. Okay. The common names of the alkyl halides are derived from the names of the alkyl groups. Here directly from the parents compound, that is name as derived, and the longest chain we have to take as the parent chain, and generally as we know that this halogen is a functional group. It is a functional group, and hence the functional group will have a higher priority, and based on that we have to name it. Now, for example, this compound, if you just see, okay, this compound, if you just see here, this compound is this is the bromide here. So the numbering is 1 2 3. So there are 3. Okay, the carbon atoms are there. The common name is N-propyl bromide, but IUPAC name is 1-bromopropane. 1-bromopropane. Now, similarly, here also we can name a number from this side 1, 2, 3 or 1, 2, 3. Once again, the same. Okay. So, here the 2, it is 2. So, that is the name we are generally representing as 2-chloropropane. Similarly, here also we can see that this is the isobutyl chloride. Now, how to numbering this? Important is how to number that. Now, the number we have to start from this, because as already I said that the halogen is a functional group, and the functional group will have a more priority according to the rule, because already you had studied the nomenclature in the first year. So detailed nomenclature you had studied, and the rules and regulations you are knowing that. Hence this will have a higher priority. So this will 1, this will 2, and this will 3. So therefore we have to write 1-chloro 2-methyl propane, because there are 3 carbon atoms are there, so they are represented in this way. Now, if we come to what is called as haloarenes, the haloarenes generally will have a same. Okay, the common name and the IUPAC names are same, but only difference is in place of the ortho, para, meta, the numberings are given. Numbering 1, 3, 1, 4, 1, 2, like that. The numbers we are giving instead of giving the ortho, para, and meta, okay, in common names. Now, for example, this compound, if you just carefully see that, it is bromobenzene. So the IUPAC name is also the bromobenzene. This is a meta dibromobenzene. Meta, so dibromobenzene. So the numbering is from this side. So this is a 1, this is 2, this is 3, this is 4, 5, and 6. Therefore, it is 1 and 3. 1 and 1, 3, 1, 3, dibromo. 2 are there, so dibromobenzene. Similarly, here also, we are also 3 bromines atoms are there, and hence it is 1, 3, 5. 1, 3, 5, tribromobenzene we are writing. Similarly, if you just take some more compounds, here you can see that this compound, okay, this compound. Now, once again, from where we will numbering, we have to start the numbering from here. 1, 2, 3. This is the longest chain, and hence the chlorine is having the higher priority. So this will get the first. So 1-chloro, 2. There are 2 dimethyls are the methyl group 2 methyls also. 2, 2, 2, 2 dimethyl propane. So that is the way we are writing, and this is a 2-bromopropane. So this is the nomenclature. We will study in MCQs much more or many more what is called as the compounds, and the IUPAC name of the compounds we will study in the later classes. The next is the nature of the CX bond. Important, the nature of the CX bond. The halogen atoms are more electronegative than the carbon. As already you know that the halogen are more electronegative than the carbon, and because of that reason, naturally there is a polarization takes place. Okay, it polarized. The bond between the carbon and hydrogen is polarized. What does it mean? The polarization is nothing but the separation of charges. The separation of the charges. How the separation of charges is taking place in the molecule? Let's see. If you take the molecule, this, and this is the X we have taken. Now, as this molecule is more electronegative than the carbon, naturally it takes slightly negative charge, and carbon takes slightly positive charge. Now, how this is possible? How this is possible? This we will see like this. Now, how many the electrons are present on the carbon? There are 4 electrons are present in the carbon. Okay. Similarly, how many electrons are present in the halogen? There are 7 electrons are present. Okay, 7 electrons are present in the outermost shell of the halogens. 7 electron. Now, sharing of the electrons are taking place here. One shared by the carbon, another is shared by the halogen, and hence it completes a octant rule like this. This is, and here there is one more hydrogen is there. Okay, one more hydrogens. Okay, there. So in this way, this also complete the octant rule. But the question arises that this, the electron pair which is lying between the carbon and the halogen is not remain at the center. It moves toward the halogen because of more electronegativity of the halogens, and hence is like this. This is the carbon and this is a halogen. This is like this. This is the way. Okay, and here you will have this, and this is of the hydrogens. So this pair is toward the halogen, and because of that reason it takes slightly negative, and the carbon takes a slightly positive charge. Now as you go to the table, okay, down the table, periodic table, what happens to the halogens? Now there are fluorine, chlorine, bromine, and iodine. Fluorine is highly electronegative compared to the chlorine, then the bromine, then the iodine. Okay, naturally, when you have the bound fluorine, the bond between the carbon and the fluorine is very strong bond, and the bond length is also very short, and hence down the group the bond length between the carbon and the halogen atoms goes on increases. Two reason is that one, the electronegativity, second is the size. The size of the fluorine to the iodine is goes on increases, as because of the sizes goes on increases, the distances goes on increases, and because of that reason the strength of the bond is increases, and because of that reason the affinity what is called as goes on decreases, and because of that reason you will have the less bound energy or enthalpy down the group. Similarly, if you just see the dipole moment here, the dipole moment between the carbon and the halogen, or carbon and the fluorine, is the highest one, and then it goes on decreases. The strong is the stronger the bond, stronger will be the dipole moment, and hence this once again goes on decreases as it goes from fluorine to the iodine. Now that is about the nature of the bond. Now we'll stop here. We'll continue in the next class.